Okay, so you've got this one in there. Again, this is a redox in acidic solution. Okay, redox in acidic. So that means you have what kinds of ions floating around in there? So you've got plenty of those ions. Notice it's with sulfurous acid, so it's definitely an acidic solution. Dichromate ions, again, those would have been there. It was probably like potassium dichromate or something that's soluble. So there's some spectator ions that are not shown in here. We end up with some chromium ions. Dichromate, by the way, when it's in a acidic solution, always produces Cr+3 ions. Sulfate ions and water are also produced in this reaction. So first step, we need to figure out what is oxidized, figure out what is reduced. The oxide is reduced. So again, look at the individual charge on each element. So go through and get charge on each individual element as you do that. Oxygen is -2 here, so we've got to figure out chromium's charge. It is a +6. So what happens to chromium? Chromium goes from a +6 to a +3, so what is that? Is that oxidation or reduction? That is reduction, okay. So we can tell right now that chromium is reduced. We can tell chromium is reduced. Remember, that means the charge goes down. In other words, chromium is gaining electrons. Okay, it's gaining electrons. If we go back through our charges here, hydrogen is a +1, oxygen is a -2. So we've got a -6 for oxygen and a +2 for hydrogen. So sulfur must be a +4. Got chromium's charge. What is sulfur right there? And this is +6. Chester. Sounds pretty right. And then you have water, +1, -2. So the elements that did not change charge, hydrogen stays +1 to +1. Oxygen's a -2 everywhere in here. Chromium goes +6 to +3, so that means it is gaining some electrons, it's being reduced. What's it being reduced by? What element is reducing chromium?
Sulfur.
Sulfur. So sulfur is being oxidized, it's losing electrons, giving them to chromium. Let's do our oxidation first. You can do either one first. So remember, we'll do half reactions for each one. So our oxidation would be, remember, oxidation is losing oil. So we have H2SO3. Okay, it's only the sulfur element that is being oxidized. SO4 -2. So first step, sulfur's charge goes from +4 to +6. That means it had to lose how many electrons? 2. So remember, instead of writing -2 electrons, we're going to write, like the algebra, you can move the other side and say +2 electrons over there. Now what? So we do electrons to equal out the oxidation number. We add in hydrogen ions to equal out the overall charge. So when I say that, this charge right here is a 0 charge. This side we have the overall charge here is a -2 and -2. So you're not looking at sulfur's charge, you're looking at the overall. So that's a -4 and this is 0. So which side we could add hydrogens to? To the right. We would add 4 hydrogens on there. Now we add in waters to equal out the hydrogens, equal out the oxygens. So if we add a water, that gives us 4 hydrogens here with our 4 hydrogens over there, 3 oxygens plus 1 there is 4 oxygens there. So the water will generally tell you if you did things right. You won't always have to add in waters. So at certain times you won't have to. This one you have to do it on both of them. Reduction. Remember, reduction is gaining electrons. So our thing being reduced is gaining. So we have, we have Cr2. So our chromium is being reduced from +6 to +3. Here's a big mistake people make. Up here we have 1 sulfur atom and 1 sulfur atom. Here we have 1 chromium and 2 chromium. So we do have to make sure those are equal first. That's going to change our number of electrons that are gained in reduction here. So each chromium is going from +6 to +3. That means each chromium is gaining 3 electrons. But there's 2 chromiums doing that, so that would be +6 electrons. Where are those 6 electrons coming from? sulfur. Okay. From sulfur. And each sulfur is given 2, so it's going to take 3 sulfur atoms to do that. The overall charge here is a little bit tougher. Okay, so this is probably about as tough as one I can give you. We have a -6 and -2. Again, we're not looking at chromium's charge, we're looking at the overall. It's -8 on this side. What is the charge on the products? It is +6 because there's 2 of those. Again, we're not trying to cancel these, we're trying to equal them. So we need to add hydrogens to this side. How many of them? 14 hydrogens. Because that now gives us a +6 overall charge here and a +6 overall charge there. Now we added what? Waters. Okay, and then we can tell if we did things right pretty quickly here. Adding 7 waters, which gives us 14 hydrogens, with our 14 hydrogens there, 7 oxygens, there's 7 oxygens, so we can tell we probably did things right based on that. So now remember your electrons that are lost by the sulfur in oxidation need to be gained by the chromium reduction. So since we only have 2 electrons involved there, and 6 here, we need to multiply this by 3. It's going to take 3 sulfurs to make this reaction happen. So if I write out the whole thing, it's going to be 3 H2SO3 plus 3 waters plus a dichromate ion plus 6 electrons. We know our electrons are going to cancel, so just leave those out. Plus 14 hydrogens. There's all the reactants. Products, you got 3 sulfate ions. Plus 12 hydrogen ions. Plus your 2 chromiums plus your 2 waters. 7 waters. This is still not our net equation. Okay, that's everything combined. But we want to know net. Like for example, 3 waters were used, but how many were produced? 7. So what's the net there? Net would be 4 used, right? Does that make sense? 3 were used, 4 produced. 3 were used, 7 produced. So the net would be, those would be gone, and this would become a 4. Anything else that we can adjust? Hydrogen ions. 14 are used, but 12 are produced. So the net would be, those are gone, the net would be that 2 were used. Okay, so we're only worried about the net. If we have something that was used or produced, just worry about the net part of it. So we can, at the end, we basically just have, this is a reaction. Water would be gone over here. So we use 3 of these. Again, it's still redox. Sulfur is giving electrons to the chromium. 2 hydrogens over there. Yeah?
Why don't you multiply that oxidation by 3?
Good question. The sulfur here is getting rid of 2 electrons, and the chromium wants to gain 6 electrons. So we had to multiply by 3 because it would take 3 atoms of sulfur to give that many electrons away. Basically, just make sure the electrons are equal. 2 electrons, 6 electrons. Okay, just make sure those are equal. Good question. A little complicated. I'm going to give you, I want you to do number 56 in your book for tomorrow. I'm giving you an even one because it's got answers in the back, so you can look and see what you did. So for tomorrow, you're going to do that. The rest of the period, though, is going to be lab stuff. Turn this thing off.